Check 1, 2, 3. Check 1. 1, 2, 3. Good evening, children. Good evening, online children. Can you hear me? Can you hear me?
Yes, sir.
Right.
Yes, sir.
I think all of my grade 11, grade 10 students will participate this class, both online and physical students, two groups of physical students, my home group class students as well as Samudra class students. Okay. Uh, I wanted to finish off the unit which I started first. What was it? Turning effect of a force or a moment of force. I did the first part of this unit. First part, uh, and I told what moment of force is. Moment of force. Can you remember that? Moment of force around a point. Moment around a point is the product between magnitude of the force and perpendicular distance to the line of action from the axis of rotation. Perpendicular distance to the line of action from the axis of rotation. In symbols, we can write the moment equals force given in F, perpendicular distance in D, F into D. Force measured in newtons, perpendicular distance given in meters. Then the unit of moment of force is Newton meter, not newtons per meter. That is Newton meter. Newton meter. Okay. We did some questions based on this equation. I have memorized the things what we learned few days ago, maybe more than 1 week. I had no time to finish this topic. Before finishing the topic, we are going to learn very important theory. What is it? Principles of moment. Principles of moment. There is no such topic in your textbook, but doesn't matter. You have to learn it. What is meant by the principle of moment? Look at this. There is a wooden strip. There is a wooden strip which is suspended from its center. It is a meter ruler of 100 centimeters. This is the axis of rotation where I tend to rotate from this axis to either side of the ruler 50 centimeters each, since it is suspended by its middle. If I hang a weight of 10 newtons, weight of 10 newtons from one end means in my left hand side, 50 centimeters away from the axis. What will happen to the balance of the ruler? Yes, it will be unbalanced. The equilibrium of the ruler will be lost. The reason? The reason is the ruler gets the object gets an anticlockwise moment due to this force. It gets an anticlockwise moment, also can be known as left hand moment. Let's find the anticlockwise moment. Anticlockwise moment. If this point is A, the other point is B. If the meter rule is AB, anticlockwise moment around A. How can I find the moment? Yes, force into perpendicular distance. The force is 10 newtons. Perpendicular distance is 50 centimeters converts to meters. Then the moment is 5 Newton meter. Anticlockwise moment is 5 Newton meter. Now the meter rule is not like this. It is in unbalanced now. I wanted to bring it back to the balance mode. I need to bring the meter ruler balance again. What should I do? Don't say that the weight should be removed. Without removing the weight, how can I bring it back to equilibrium? Yes, I have to hang another weight in other side of B. If I suspend another weight of 10 newtons in the opposite side, then the object will get a clockwise moment or right hand moment. That right hand moment will balance the previous one and it will be back into balance. Find the clockwise moment again. Clockwise moment. Around B, point B. Once again, how to find it? Force into perpendicular distance. If this point is O, normally axis is given in letter O. Distance from O to B. Being this is a meter ruler, the distance is also 50 centimeters. Being it is fixed or suspended at the center. Then what is the clockwise moment? Once again, 10 newtons into 50 upon 100. It is 5. What can you tell about now? Clockwise moment is equal to anticlockwise moment. That is known as the principles of moment. What is it? When an object is in equilibrium, all clockwise moment should be equal to all anticlockwise moments. Or in other words, to become an object in equilibrium, the sum of clockwise moments, sum means ekatuwa, should be equal to sum of the anticlockwise moments. සියලුම clockwise moments වල එකතුව සමාන වෙන්න ඕන anticlockwise moment එකට. Then the resultant will be 0. What is the resultant of this system? 0. When the resultant becomes 0, there is no linear motion of this object. මේ object එකට යන්න බෑ හෙට මෙහෙට. It is in balance. That is the principle of moment. Okay? Write the topic, principle of moment. Principle of moment. Principle of moment. Write this. A meter ruler is a meter ruler is balanced. Meter ruler is balanced from its center. From its center, stop. 10 newtons of force, weight, 10 newtons of weight is hung. 10 newtons of weight is hung. Weight is hung in left hand side. In left hand side, 50 centimeters away from the axis. 50 centimeter away from the axis. Away from the axis. Then the ruler gets an anti-clockwise moment. Ruler gets an anti-clockwise moment. Due to that, moment, the ruler becomes unbalanced. The ruler becomes unbalanced. Ruler becomes unbalanced. To bring the ruler back into equilibrium, to bring the ruler back into equilibrium, to bring the ruler back into equilibrium, another weight should be hung from the other side. Another weight should be hung from the other side. From the other side. Then the object will get, or then the ruler will get clockwise moment. Ruler will get the clockwise moment. Clockwise moment. Get the clockwise moment. Another rule. According to the principle of moment, according to the principle of moment, according to the principle of moment, clockwise moment should be equal to anti-clockwise moment. Clockwise moment should be equal to the anti-clockwise moment. Anti-clockwise moment when an object is in equilibrium. When an object is in equilibrium. Is in equilibrium. Right. Now you can clear the story here. What happens that you have to copy down this diagram, put the data and find the anti-clockwise moment and clockwise moment and see how they equalize. Do it now. Draw the diagram and find anti-clockwise as well as clockwise moment. Both moments are equal. Okay, have you finished writing? Have you finished writing? No. සමුද්‍ර කොලෙජ් එකේ දරුවෝ උතන ඉන්නවා නම් ක්ලාස් එකේ ඔයගොල්ලන්ගේ බයොස්ෆියර් ටියුට් එක ඔන්න අද දවල් වෙද්දී සමුද්‍ර ආයතනයෙන් දීලා තියෙනවා ගිහිල්ලා ගන්න පුළුවනි දැන් අද දවල් සමුද්‍ර කොලෙජ් එකේ තියලා තියෙනවා උදේ සාමාන්‍යයෙන් 8 වගේ ඉඳලා හවස 5 විතර වෙනකන් වෙලාවෙ තියෙනවා ඒ වෙලාව තුල ගිහිල්ලා ගන්න පුළුවනි එහෙම නැත්නම් next Saturday ආවම ඉල්ල ගන්න. අනිත් දරුවන්ට ගෙදරින් ගන්න පුළුවන්. Okay. Have you finished writing? Since nobody is answering, I'm go for the next one. Look at this figure 2. According to this law, an object is suspended like that. If W1 weight is hung, D1 distance away from the axis, it gets an anticlockwise moment. To make it balance, another weight of W2, it won't be equal to the first one. You can adjust it from the distance. W2 should be hung D2 distance away from the axis. According to the principles of moment, according to the principle of moment, anti-clockwise moment equal to clockwise moment, or left hand moment equals to right hand moment, or either you can write clockwise moment equal to anti-clockwise moment. Any. Anti-clockwise moment should be equal to clockwise moment. When the object is in equilibrium, make a balance with the විතරයි. Anti-clockwise moment means W1 into D1 should be equal to clockwise moment means W2 into D2. If you know any three of these four factors, you can find the fourth one. If you know W1, W1, D1, D2, you can find W2. If you know D1, W2, D2, you can find W1. The similar way, you can find D2 and D1 also. What you have to do is just to subject what you want. Knowing three factors, you can go for the fourth one. So that is the importance of moment of force. As example, if 100 newtons of force is hung from 100 newtons of force is hung from 0.5 meters from the axis. 0.5 meters from the axis. What is the distance that 50 newtons of force should be hung to make it balance? That means what is D2? 100 newtons of weight is hung from one side, 0.5 meters away from the axis. It is not a meter ruler, maybe longer than that. Okay? Then you are given just 50 newtons of weight to make this rod balance. Half of the weight given. Where should you, where that weight should be hung? Find D2. W1 given, D1 also given, W2 is given, find D2. W1
One
is 100, yes, 100 newtons. D1 means 0.5 meters. W2 just 50 newtons. Find D2. Substitute the values for this equation. W1 equals 100. D1 equals 0.5 meters equals W2 is just 50 newtons. Find D2. Subject D2. D2 equals 100 newtons into 0.5 meters upon 50 newtons. It is 1 meter. So 50 newtons of force should be hung 1 meter away from O. D2 should be 1 meter then. Simply you can understood what happens here. The previous weight was 100, but you are given half of that. Then you have to increase the length double. Otherwise, you can't get the previous moment. Moment of force depend on two factors, either magnitude of the force or the perpendicular distance. If the magnitude of the force is halved, then the perpendicular distance should be double. On the other hand, if you are given 200 newtons of force, without calculation, tell me from where the 200 newton of force should be hung. From O. 200 is the twice of the first weight. To bring this object in balance, where the 200 newton should be suspended. Yes? 200 newtons means twice of the weight in other side. Then to make the rod in balance, you have to half the distance. If the distance of 100 newton is 0.5 meters, then 200 newton should be hung half of this value, 0.25 meters. That means 25 centimeters away from O. Because 100 newton force is hung 50 centimeters away. To keep this, to maintain this constant, either magnitude of the force or perpendicular distance should be adjusted. Right? That's the principle of moment. Can you copy this question too and get the answer as 1 meter? Find D2. Put the values to D1.5, W100, W250, and D2. Finished? Shall I erase this? Okay.
No, sir. Okay, sir.
Another question. A rod of AB is 1.3 meters long. This rod of AB, 1.2 meters long. It is kept in equilibrium by suspending, not from its, yes, from its center. It can be balanced like this. No need to suspend. You can balance it over such a pivot. මේ වගේ pivot එකක එහෙම නැත්නම් මේකට කියනවා අපි point එකක් කියලා. මේ වගේ තැනකින් balance කරන්න පුළුවන්. Maybe you can use a knife edge. A ruler can balance from a knife edge. If 10 newtons of force is kept at one end, now if it is balanced at its center, if the length of this rod is 1.2 meters, what would be this distance? Distance from this object to the axis of rotation. Can you guess it? The length of this rod is 1.2 meters. It is suspended, sorry, not suspended, it is pivoted at its center. Then what this distance would be?
0.
Yes, 0.6. Half of 1.2, 0.6 meters. Hari bhagyak ne, hari මැදින්නේ. From axis to the other end. මේ කෙලවරට. What is the perpendicular distance? How much? Another 0.6 meters. Another 0.6 meters. But another object is placed not at the end of that end, at the middle of that end. That weight would be W. Is placed 0.3 meters away from the axis, not 0.6. Now, if the rod is in balance, what should be the value of W? What the weight should be kept?
20
0.3 meters away from its axis. Apply the principles of moment. Okay, you can do yourself. Copy the diagram. Copy the diagram and get a value. මේ වගේ දේවල් මනෝමය හදන්න පුළුවන් මම දන්නවා. නමුත් පිළිවෙලක් තියෙන්න එපයි. ස්ටෙප්ස් විදියට යන්න එපයි. Yes. Which type of moment given by 10 newtons of force? Always weight acting downwards. 10 newtons of weight acting downward. Due to that weight, the rod gets an anti-clockwise moment. It tends to rotate anti-clockwise direction. එයා මේ පැත්තට කරකින්න බලනවා. මේ weight එක නිසා. To make the rod balance, you need a clockwise moment, opposite moment. It is given by the other weight, W. It rotates the rod opposite, clockwise. These two should be balanced to bring it back into equilibrium. Then the clockwise or anti-clockwise moment. Anti-clockwise moment should be equal to clockwise moment because the object is in balance. Anti-clockwise moment exerts by 10 newtons of force 0.6 meters away from the axis should be equal to the clockwise moment. Clockwise moment given by W weight, unknown weight, 0.3 meters away from the axis, half of that distance. Then find W, the weight that should be hung. Oh, sorry, not hung, placed. 10 newtons into 0.6 newtons divided by 0.3 meters. W is 20 what? Meters, meters,
Newton.
newtons. It's a weight. That weight is twice of the first one because it is kept half of distance from the axis. Understood? Copy this. Another question. Finished? Yes. Third question. Another uniform rod, which is pivoted at its center, point B. B is the axis. It is the center of this rod. Okay. A is one end. C is the other end. 10 newtons of force is hung. 10 newtons. (2 meters) away from axis. Another 2 meters from 10 newtons to A. So you will realize the length between AB. Another 10 newtons of force is hung at the other end. Once again, 2 meters away from the axis. Another 2 meters to end C. 20 newtons of weight is placed directly on B. Not two, there are three forces acting here. It's a system of forces. කලින් questions වල forces දෙකයි තිබ්බේ. දැන් කීයක් තියෙනවද? Three forces acting here. Two 10 Newton forces and one 20 Newton force. You have to determine the moment around point A, B, C. මේ points තුනේම වෙන වෙනම හොයන්න ඕන moment එක. Okay? Find the moment around point A, වටේට, point B, and point C. How can you find this? Moment around these 3 points respectively. වෙන වෙනම හොයන්න තියෙන්නේ. එක සැරේ හොයන්න බෑනේ. Always the moment has an axis of rotation. Moment කිව්වහම කැරකි වෙන තැනක් තියෙන්න ඕන axis එක. If that rotating point is A, find the moment around A. If the rotating point is B, find the moment around B or C. Copy the diagram and find it. If you can, then I'll help you.
මම උපදින්න තව දවස් 10යි තියෙන්නේ.
Please mute the microphone. Priya, mute the microphone.
I'm sorry, sir.
Okay. Yeah, වෙනස් විදිහේ question එකක් නේද? Oh. Let's find the moment around point A first. Right, now you are in here, point A. Now look at the clockwise and anti-clockwise moment that you have. There is a 10 newtons of force acting downwards. Because of that, the rod gets clockwise moment. Right. There is another 10 newtons of force acting just 2 meters away from A. It also exerts a clockwise moment. These two clockwise moments are balanced by 20 newtons of force acting upwards. That upward force exerts an anti-clockwise moment. එයා හදන්නේ anti-clockwise moment එක. Two clockwise moments balanced by single anti-clockwise moment. See whether the sum of moment equals to 0. The sum of moment should be equal to 0 because the rod is in balance now. Moment around A. Moment around A equals clockwise moment and anti-clockwise moment. What are the clockwise moment? Clockwise moment equals to anti-clockwise moment. Anti-clockwise moment. There are two clockwise moments, 10 newtons. This 10 Newton force is 2 meters away from A. Now don't look at point B. Your axis is A. So the perpendicular distances are measured from A to the line of action of the forces, okay? This 10 newtons of force is 2 meters away from A plus, because it has another one, another 10 meters force. This one. It is 1, 2, 3, 6 meters away from A into 6 meters. Am I correct? Count the distance from A to this 10 newtons force. 2 plus 2 plus 2, 6 meters. It should be balanced by a single anti-clockwise moment given by this force, 20 newtons. 20 newtons of force is 4 meters away from A. Perpendicular distance is 4. 10 into 2, 20. 10 into 6, 60. 20 into 4, 80. 20 plus 60, 80 Newton meters. It is equal to opposite moment. See that? The moments are balanced clockwise and anti-clockwise. That's why the object is in balance. In that way, you can find the moments around point B as well as C. ඒ විදිහට අනිත් දෙකේ හදන්න බලන්න. Find the moment around B. Okay. Once again, clockwise moment should be equal to anti-clockwise. Now you are in B. Find the clockwise, anti-clockwise moment acting around B. There are only 10 newtons of forces acting. One is acting clockwise. The other one is acting anti-clockwise this time. Then මේ අනිත් පැත්තට act වෙන්නේ. මේ අතට anti-clockwise. Then what happened to these 20 newtons of force? This 20 newtons of force is directly is on B. Is there a perpendicular distance from 20 newtons to B? No, 0. Therefore, no effect of these 20 newtons of force if you consider the axis as B. B කියන axis එකේ ඉන්නවා නම් මේ 20 newton එකකින් වැඩක් නැහැ. Perpendicular distance එකක් ගන්න බෑ. Then you will have only two forces, anti-clockwise and clockwise. Clockwise force is given by this 10 newtons of force. This one. 10 into perpendicular distance from B. How much? 2 meters. Anti-clockwise moment exerts by the other 10 newtons. Opposite. May I balance? It is also 10 newtons into 2 meters. See that? Once again, it is balanced. 20 newtons each. That is the moment around point B. Then find the moment around point C. Moment around point C. Now you are in here. What are the forces acting? Yes, there are 3 forces. 10 newtons of force nearby. To which direction is act? මෙයාගේ බර නිසා කොයි පැත්තද කරකෙන්න බලන්න. මෙහාට. Clockwise. You will have another 10 newtons of force. It is 1, 2, 3, 6 meters away. Because of that weight, it rotates anti-clockwise direction. Don't forget that you will have this 20 newton of force 4 meters away from C. It acts clockwise direction. At the clockwise. May clockwise moment. Then write the clockwise and anti-clockwise moments here. Clockwise moments. All clockwise moments. All clockwise means that there are 2 clockwise moments. One is this 10 newton. 10 newton into perpendicular distance 2 meters plus. So what is the other one? This 20 newtons of force. 20 newtons. It is 4 meters away from the axis. These 2 clockwise moments are balanced by a single anti-clockwise force, 10 newtons, this one, which is 6 meters away from the axis. 10 into 2, 20, plus 20 into 4. Wait. 4. පොඩි වැරදීමක් කියලා තියෙනවා මෙතන. පේනවද මොකද්ද කියලා? හොඳට බලන්න. අපි ඉන්නේ මෙතන. We are in here. C. This 10 newtons of force. This 10 newtons of force is acting anti-clockwise. මෙයා ඉන්නේ මේ පැත්තට. අපි මෙතන ඉන්නේ. The other 10 newtons of force is also acting anti-clockwise. 20 newtons of force acting clockwise direction. Here the clockwise moment, these 2 are anti-clockwise. The only clockwise moment is 20 newton. 20 newton into 4 meters. It is balanced by two anticlockwise moment. One is 10 into perpendicular distance 2 meter plus 10 into 1, 2, 3, 6 meters. 80. 80. What is that question? That question is the last question in your textbook in exercise. Textbook එකේ ඔය පාඩම අවසානයේ තියෙන exercise එකේ අන්තිම question එක දීලා තියෙන්නේ ඔය මම. It came several times in term test, not in the O-level exam, in term test. You should be able to think in this way too. It's not traditional one. You have to think beyond that. සාමාන්‍ය clockwise anti-clockwise forces දෙකයිනේ තියෙන්නේ. මේකේ 3ක් 4ක් 5ක් ඕන තරම් තියෙන්න පුළුවන්. මේ විදිහට හිතන්න බලන්න. If the rod is in balance, if the object is in balance, the sum of all moments should be zero. Moments ඔක්කොගෙම එකතුව 0 වෙන්න ඕනි. Then the resultant becomes 0. As you learned in the previous lesson, to become an object in equilibrium, the main requirement is the resultant should be 0. Is it clear? Understood? Right. Now we go for the last lesson of this unit. Last lesson. Look at this. A wooden strip, which is fixed at the middle, at the center. It can rotate around this point. Okay, it is at the center. Using the Newton balance, 10 newtons of force is applied from one end, x. Using another Newton balance, a similar force is applied. This time to opposite direction at B. Two equal, parallel, opposite forces acting equal distance from axis of rotation. What will happen to this rod? What kind of motion can be seen in this rod? මොන විදිහේ චලිතයක් බලාපොරොත්තු වෙන්න පුළුවන්ද? Two equal opposite forces acting parallel to each other in opposite directions from equal distances. To which direction the object moves? Will it move forward or backwards or anything else? Now, according to the principle of moment, Newton balance B exerts a clockwise moment. Newton balance A, not X, should be A, exerts anti-clockwise moment. Since these two moments are equal in magnitude, you can see the linear motion of this object. මේ දෙන්න සමානයිනේ. පේනවනේ සමානයි කියලා. සමාන දුරින් නම් සමානයි. If these two distances are D, the moment will be FD equal. Then no linear motion of the object can be seen. Object එක ඉස්සරහට පස්සට යන්නේ නැහැ. But it will tend to rotate. හැබැයි කැරකෙන්න බලනවා. Will rotate around point O. O කියන කෙනා වටේට මෙන්න මෙහෙම කරකැවෙනවා. There is a rotational motion. Such a system is called a couple. This is called a couple or couple of force. In Sinhala, bala yugmaya. So what is a couple? Two equal parallel forces acting opposite to each other from equal distances from axis of rotation. You can find a lot of examples in your day-to-day life for a couple, like a steering wheel of a vehicle, bicycle handle, using a screwdriver to tighten or remove a nail, using a key door to open a door lock. A butterfly nut is rotating. A Tommy bar is used to loosen the nuts in the vehicle engine. Lot of examples. Seesaw in a park, a couple is there. Okay. What are the conditions to be fulfilled? Forces should be equal in magnitude. සමාන වෙන්න ඕන විශාලත්වයෙන්. Are they collinear? No, they are not collinear. They have two different lines of actions. They are parallel. They are parallel and opposite, but equal distances away from the axis. Shall we write a couple? Okay, start writing. Write a subtopic as couple or couple of forces. Couple. Two coplanar forces. They are coplanar, okay? Coplanar means both have the same plane. Two coplanar forces. Two coplanar forces. Two coplanar forces of equal magnitudes two coplanar forces of equal magnitudes acting in opposite directions. Acted in opposite directions. Acting in opposite directions. Opposite directions, comma, equal distances from axis of rotation. Axis of rotation is known as a couple. Is known as a couple. Couple forces are not collinear. Couple forces are not collinear. They're not collinear, but parallel to each other. Parallel to each other. Parallel to each other. Right. If I put some letters here, if this is a F, this should be F2. Okay. If distance D is just 1 meter, here 1 meter also, how can we find the moment in such a couple? කොහොමද මේ couple එකේ moment එක හොයන්නේ? Moment of a couple. Moment of a couple is the product between magnitude of one of the force. මේ දෙන්නගේම magnitude එක සමානයිනේ. එහෙනම් එක්කෙනෙක්ගේ විශාලත්වය ගන්නවා අපි. Magnitude of one of the force into perpendicular distances between the two parallel forces. මේ දෙන්න අතර දුරින් වැඩි කරනවා. Perpendicular distance between two forces, two parallel forces. Is it the perpendicular distance from axis of rotation to the line? No, no, no. Perpendicular distance between the two forces. Forces දෙක අතර දුරින් වැඩි කරනවා. Then you will get the moment of such a couple. මෙහෙමයි හොයන්නේ couple force එකක moment එක. Moment of a couple. Okay. Can you copy the diagram first? Draw this couple. Put the values. Don't write the equation yet. Moment of a couple equals force into perpendicular distance between two forces, two parallel forces. Then write below, in order to find the moment of force around a couple, in order to find moment of force around a couple, in order to find moment of force around a couple, moment of force around a couple, the force should be multiplied by the force should be multiplied by force should be multiplied by the perpendicular distance between the two parallel forces. Between the two parallel forces. Right. Then write the equation to find the moment around this moment of this couple. Moment around this couple. Okay. Let's find the moment of this couple. Substitute in values for this equation. Okay. Moment of the couple equals magnitude of the force 10 newtons. Perpendicular distance between the two forces 1 plus 1, 2 meters. It is 20 Newton meter. So that is the moment of this couple. 20 Newton meters. Solid. 20 Newton meters. So we can go for similar question in your textbook. Let me show you. In your text. Yes. I think there is a printing mistake in this question. No, there is no printing mistake. See how the moment of force is made. O is a point which is pivoted. 10 newtons of force is given from one end. Equal force is given opposite. But it is not fixed at the center. හරි මැදින් නෙමේ හයි කරලා තියෙන්නේ. 0.4 meters 0.4 meters from O to that end. 0.3 meters from O axis to the other end. Then they ask the moment of force of this couple. Moment of force means force into perpendicular distance between the two forces. That means 0.4 plus 0.3. It is 0.7. Then the moment in this couple is 7 Newton meters. 7 Newton meters. Always get the perpendicular distance between the two parallel forces. Okay. In a couple, there should be a rotational effect. අනිවාර්යයෙන්ම කරකැවෙනවා කපල් එකක් තිබුණොත් එතන තියෙන්නේ ටර්නින් ඉෆෙක්ට් එකක් නෙමෙයි ටර්නින් ඉෆෙක්ට් එකක් තමයි ඊට වැඩි එහාට ගියපු එකක් මොකක්ද rotation එකක් තියෙන්නේ rotation එකක් right the last one applications of couple forces write the subtopic you are going to draw few applications of couple. Number 1, steering wheel of vehicle. Steering wheel of a vehicle. Children, you have to show the couple in the exam to which direction it act and මේවා ඇඳලා පෙන්වන්න සිද්ධ වෙනවා exam එකේ. ඒකයි මේ. How can you show the couple force? Here is one. This is the other one. These two couple forces given by the two hands. Opposite, equal. Okay? Opposite and equal. Bicycle handle, when you turn in the bicycle. Number 2. Turning of a bicycle handle. Here is the handle of the bicycle. By the two hands, two equal but parallel opposite forces given. Then the bicycle will turn. Okay. When using a screwdriver, third one, using a screwdriver to loosen or to loose or tight होने का a nail, screw nail. How does it work? This is the handle of the screwdriver. Here the axle. When you rotate it using your two fingers, the handle will rotate like that. Two parallel forces given by the two fingers on the handle. Similarly, the key of a door lock can be used. A butterfly nut. මේවට කියන්නේ butterfly nuts කියලා. මේ වගේ nuts දැකලා ඇති. How do you tighten the butterfly nut? Applying two parallel opposite forces. Opening or closing a water tap. Opening or closing a water tap. Couple force is given to the handle of the water tap. It will rotate then, given by the two fingers, rotate in the water tap. So many examples. You have to write few more examples in the exam, and sometimes the diagrams will be given. You have to show the direction of the force acting. That's why I drew them on the board. Where diagrams දීලා වගේ forces mark කරන්න එනවා. එහෙම නැත්නම් සම්පූර්ණ diagram එක අඳින්න එනවා. Two examples for couple forces like that. මේ තියෙන්නේ මොකක්ද මෙතන? Using a screw driver. Screwdriver. Here the fifth one, this is the sixth one. Fifth one is rotating a butterfly nut. දැන් මේව අඩුයි හොයාගන්න. එතන ඔය තිබේ ඇන්ටනා වල. දැන් ඇන්ටනා නැහැ ඩිස්ප්ලේ තියෙන්නේ ඔක්කොම. ෆයිබර්. ඇන්ටනා වල ඉස්සර අපේ පොඩි කාලේ අපි ඔය කරකවලා තියෙනවා මෙහෙම. ඇන්ටනාව යන මෙහෙම කූරු තියෙන්නේ. මේ හැම කූරකටම තියෙනවා බටර්ෆ්ලයි නට්ස්. ටයිට් කරන්න ඕන. තව තියෙනවා ළමයි එන්ජින් වෙහිකල් එන්ජින් එකේ කොටස් ගලවන්න. මෙන්න මෙහෙම ටොමි බා කියලා එකක් තියෙනවා. මේකට වෙන නමකුත් ඇති ස්පෙෂල් නේම් එකක්. මොකද එන්ජින් එකේ ඇතුලේ ගොඩක් දේවල් තියෙනවා අතපොවන්න බෑ. ඉඩ නැහැ. no space there. මෙන්න මෙහෙම item එකක් හොඳට බලන්න. Tomiba. මේ කොටස engine එක ඇතුළට බස්සනවා. මෙතන ඉන්නුයි මෙතන දෙනවා couple force එකක්. මෙහෙම ඈතින් කරකවනවා මෙහෙම. කරකවපුවාම මැද තියෙන axle එකෙන් මේකෙන් screw එක ගැලවෙනවා. Tomiba. Tomiba. Just like a vehicle steering wheel. Right. Have you got an idea of a couple? Yes. Can you find the moment of a couple? Yes. Don't forget to get the perpendicular distances between the two forces. Can you tell me the characteristics of a couple? What are the characteristics of couple? Yes. Two equal forces acting opposite to each other, parallel forces, coplanar forces, acting equal distance from the axis of rotation. Once again, two equal forces, parallel forces, coplanar forces acting opposite to each other. That is a couple. Now, I think it's better to wind up the class because this unit is finished now. We have no time to start the biosphere next week, most probably Sunday morning or Sunday night. Maybe Sunday night. The biosphere or classification of organisms will be started after giving the tute for you. මම කල්පනා කරා ටියුට් එකත් අතේ තියෙද්දි කරොත් හොඳයි. සමුද්‍රයේ තියලා තියෙන පුතේ දවල් තිබ්බා. මේ දවස් ටිකේ ගිහිල්ලා අරගන්න. නැත්තම් සැටර්ඩේ ගන්න. ගෙදර ක්ලාස් වෙන දරුවෝ එහෙම අවශ්‍ය නැහැ. ඉරිදට මම මෙහෙන් දෙන්නම්. ඉරිද හවස අපි ක්ලාස් එක කරන්න බලමු ඉරිද රැට. සුමින්සේ ක්ලාස් ඉවරනට පස්සේ මොකද උදේ වරුවේ මට හිතෙනවා ඔයගොල්ලෝගේ ඇටෙන්ඩන්ස් මදි වුණා. මොන හරි දේවල් ඇති. දැන් අද හවස හොඳයි. 70 ගණක් 80 ගණක් විතර හිටිය ජොයින් වුණානේ. හරි? ඒ වගේ සන්ඩේ ඊවිනින් ක්ලාස් එක කරන්න try එකක් දෙමු අපි. කොහොමත් බයොස්ෆියර් පාඩමත් මට කරන්න සිද්ධ වෙනවා මේ විදිහට. ටියුට් එක අනිවාර්යයෙන්ම ලබා ගත යුතුයි. ඒකේ ලියන්න තියෙනවා. නෝට්ස් ගොඩාක් ලියන්න මුකුත් නැහැ. ටියුට් එකේ විස්තර ටිකක් ලියන්න තියෙනවා. ඒ හින්දා ටියුට් එක ලබා ගන්න කොහොම හරි. යන්න ගිහලා සමුද්‍රයෙන් ඉල්ල ගන්න. ඕකේ. ඔන්න අපි ෆිසික්ස් යුනිට් ටික ඔක්කොම කවර් කරා. සෙකන්ඩ් යුනිට් එකේ ආයි ෆිසික්ස් නැහැ කොහෙවත්. ඉතුරුලා තියෙන්නේ බයොලොජි යුනිට්ස් දෙකයි chemical bonds කියලා එකක් තියෙනවා. ඒක එක group එකක් නෑ ඉවරයි. සමුද්‍රයේ ළමින්ටත් ඒක ඉවර වෙයි. හරි? chemistry biology විතරයි ඉතුරුලා තියෙන්නේ. physics පාඩම් 3ක් ඉවර කරා එක සැරේ. Okay? Right. Then good night children.